Today we're going to look at Diophantine equations, and we are going to solve one, and we're going to have a little bit of a look at general solution so you can understand what's going on with the multiple solutions. Now, the type of equation that we're looking at is a linear combination, and it's the type of equation you'll be familiar with from doing simultaneous equations with elimination, but you'd expect to get two, and then you'd solve for x and y, and you'd get one set of solutions. In this particular case, we're only given one equation, and what we want to find is integer solutions only. So we're not looking for fractions here, we're just looking for integer solutions. And there will be more than one option. Not all equations of this form have integer solutions, but there's a way to check for that, and we'll do that as we go through the working. So we're going to be using the Euclidean algorithm, and we'll do that as we would normally. So we're going to start by finding the greatest common divisor of 5 and 7. We know it's going to be 1, but we're going to go through the working so we can do the extended algorithm. So 7 is 1 lot of 5 plus a remainder of 2. 5 is 2 lots of 2 plus a remainder of 1. 2 is 2 lots of 1 plus a remainder of 0. So we know that our greatest common divisor is 1. At this point, we're going to check if this number is a factor of the answer in our original equation, and it is. It's 10 times. So now we're going to work backwards and express 1 in terms of 5 and 7. So starting from here and rearranging, 1 is equal to 5 minus 2 lots of 2. And then remember, we're substituting the 2 from here, and 2 is the same as 7, take away 1 lot of 5. So 1 minus 5, take away 2 lots of 7 minus 5. And we'll expand that out. So 1 is equal to 5 minus 2 lots of 7 plus another 2 lots of 5. So it's 3 lots of 5 minus 2 lots of 7. So 3 lots of 5 minus 2 lots of 7 are equal to 1. And if we have a look at our original equation, I've just moved everything up a little so that we could fit it on this screen. Original equation said 5x plus 7y equals 10. So what we're going to do here is we're going to multiply everything by 10 and then compare the two. So we then have 30 lots of 5 minus 20 lots of 7 is equal to 10. And we'll compare it to 5x plus 7y equals 10, and therefore we can conclude that x is 30 and y is negative 20. And that's our first set of solutions. Remember, as always, in this case we can do a check, which I'm going to do just now. So 5 times 30 plus 7 times negative 20 is 150 minus 140, which is in fact 10. So I'm happy that we've got the correct set of solutions. Now there are more solutions, and what we're going to do is we're just going to find one more, and then I'm going to go through the principle of how this is true, and you can see that we could find multiple sets of additional solutions. Now, to get our second lot of solutions, what I'm going to do is I'm going to get my new x. Now first we're just going to look at how to find the next set of solutions. So for x, I'm going to value, and I'm going to subtract 1 lot of 7. Get a new value of 23. For my y value, I take my negative 20, and in this case I'm going to add 1 lot of 5, which will give me negative 15. And at this point we have actually found the solutions. One more set of solutions. We'll just check. So substituting into the equation above, 5 times 23 plus 7 times negative 15 is equal to 115 minus 105, which is 10. So yep, those values work. Why is that? Let's have a little look and see what's happening. Okay, let's just see what we did there in algebra. So for our new value of x, we took what we had was our normal x and we subtracted 7 from it. To get our new value for y, we took what we had as y and we added 5. I'm going to pop those back into the original equation. So I've got 5 lots of my original x, take away 7, plus 7 lots of my original y, plus 5. If I expand those brackets out, I've got 5x minus 5 lots of 7, plus 7y, plus 7 lots of 5. And you can see that I've got negative 35 plus 35, so I end up with just 5x plus 7y. And that will happen every time. As we said earlier, I could have chosen to add the 7 and take away the 5. I can also do multiples of, so I could do minus 14 plus 10, for example. Let's have a little look at the general form, just so that we're sure we understand why. Okay, so I've got an equation here, ax plus by equals c. Now, if I take the x and y that I've worked out in my first solution, so I take the value that I've worked out for x and I'm going to add 1 lot of b to it, and then I'm going to take the value that I have for y and I'm going to subtract 1 lot of a. When I expand those out, ax plus ab plus by minus ab, which means that I'm left with ax plus by, which we know is equal to c. So the key is in this part here, where these are always going to cancel out. And again, that could be multiples of. I hope that helps. I've given you a few to try yourself at home. Ask me for help if you need it.